Is that changing my? Yeah, it is affecting me a little bit. Well, that's okay.
Trying to get myself a bang slap in the middle. That's better.
Yeah. I did notice you're a bit on one side, but that's
Offside, off-centered.
Off-centered.
I could have just pushed the camera along the top of the bit. But
yeah, you can. Maybe that'll be better than you moving. You can't do that, Paul. It does move. Hello and welcome to the Cloud Therapist channel. I'm Richard Simon. This is the April 2023 edition of Cloud State of Play. As always, I have Paul Bevan back in for more topical discussions. Paul is the Director of Research for Infrastructure at Bloor Research. Let's say hello to Paul. How are you doing, Paul?
I'm good, thank you, Richard. And yourself? Yeah.
Excellent. So, Paul, for this month, we've again picked on 3 topics for us to go through, and they are as follows. First one is the state of cloud server and storage infrastructure. So Paul's going to enlighten us about some of the stuff that he's picked up on in that space and kind of explain what he means by all that in a little bit more detail. The second one is, how does data live in a stateless world? Very good question. So we're definitely going to go through a little bit more data information in regards to how data lives in that stateless world and discuss that. And the third one, which I brought to the table, is AI and kind of the progress of AI, and why is it kind of happening now? Why we got ChatGPT just now? Why didn't we have it, 2 years ago or 5 years ago? So again, that'll be an interesting one to go through. So, Paul, let's kick off with the first one, the state of cloud server and storage infrastructure. Okay.
So really, this is a sort of shout out to what I think is a sort of slightly forgotten area of cloud development. Because if you look at the story of the cloud, it is largely a software-driven one. I mean, you go back to 2011 and Mark Andreessen going, software is going to eat the world, and he actually meant software is going to eat the hardware. And then you look at, virtualization, moving to software-defined data centers, to infrastructure as code, and to composable infrastructure. I mean, you could be forgiven for thinking whatever happened to the hardware, has it just become a commodity, an x86 pizza box we used to talk about, and racks and racks and racks of those. And so I've just thought we needed to sort of come back and have a look at the way in which the cloud and the infrastructure has had a sort of symbiotic relationship. On one hand, the way in which the cloud has developed is driving a whole load of new developments around infrastructure, and I'll come back to those. But also, the cloud has to thank the infrastructure for being able to deliver the sort of the power and the availability and all those sort of issues. So I just thought, in all the sort of software discussions everybody has, it would be worth bringing to the attention of people that actually there's quite a lot going on there. So let me sort of come back to this idea of, just standard commodity hardware. To a point, if you come back to the sort of around about year 2000, and there was a big debate around how are you going to scale everything? Were you going to scale out or scale up? There was a big debate there, and by and large, scale out won over scale up. And give you some examples of quite innovative scale up architectures that never really took off. But the reality was that, the way in which scale out worked, the way in which some of the leaders like Facebook, like LinkedIn, and Amazon and Google and others themselves worked their magic with banks and banks and banks of servers, enabled the cloud to take off. But the way in which we're now using the cloud means that a lot of pressure has been put on those standard x86 architectures, and the notion that everything happens within the x86 chip. So what we're seeing is a number of different factors coming into play. Firstly, if you look at, the first is really about the whole ARM risks, environment coming in, where the needs of HPC, high performance compute, was proving a little hard for a standard x86 architecture to handle. And therefore, it was finding that risk-based architectures, so that reduced instruction sets rather than the sort of complex instruction sets that is an x86, were better suited to that. So you get the whole sort of ARM story coming in. But the cloud has also driven a whole series of requirements around performance and latency and availability that led people to actually offload a lot of the processing that the main processor is handling into specialist chips or processors. So you think of graphics processors, GPUs for gaming. Suddenly, people realized that they were really good for AI processing. It was the same sort of mathematics going on. But then you've got field programmable gate arrays too, that were offloading functions from the main processor, simply because you're running out of capacity. Moore's law slowed down. There's a sort of come a point where you can't keep doubling the output and halving the price over the course of 2 years. It just was stopping, and therefore, but the sort of inevitable growth of applications and different types of applications in the cloud meant that putting pressure on those architectures. And one way to deal with that was to offload offload the network processing, offload the storage processing, but offload some other functions as well. So you've got graphics processors, you've got field programmable gate arrays, you've got specific processors for data storage, specific processors for networking, so beyond the NIC, actually beyond the network interface card, you're going into sort of processors for that. And so I think the main story here, and the sort of thing you want to put out is, if you're relying on the big hyperscalers, or you've got a cloud provider that's doing everything for you, you probably don't have to worry about that. But if you're thinking of getting into some of these areas yourself, and you're not, and you're going to have the hardware on your own, in your own premises, then you need to be aware that it's got a lot more complex. So, I mean, I'll give you an example. I was working recently, sort of late last year, I think, with a company that's building a platform for high performance trading in the financial services market, high frequency trading. And the requirements there had tended to suggest you had to have very specific configurations on site. You couldn't go to the cloud. And actually what this company was done is to build a version in the cloud with very, very specific, specific processes handling specific tasks, in such a way that they could provide the sort of latency and performance that you get from the older system. So I think there are very specific areas where that's happening. But if you look at it, I just think that's going to be a growing trend, that in terms of latency, performance, availability, you're going to have to keep doing these things. It might be music to your ears, it might be a reason why people say, there's no way I can do this myself. I'm going to leave it to AWS or GCP or Azure to handle that, or one of the other ones. But that's the reality. But it is feeding back into the cloud to drive, and I think we may come at this later in one of your other subjects. It's feeding back into the cloud the ability to drive more and more applications, because the applications are getting more and more complex. They're getting mission critical. Cloud, you've gone back 5-10 years and people are saying, oh, well, cloud's not right for mission critical. Well, of course it is right for mission critical. Let's not kid ourselves. But again, that's been facilitated by what's happening. And you now look at memory. You've got sort of persistent storage in memory. So flash came along, SSDs, NVMe, everything that's making it quite a complex area for companies to get their heads around of, what do I need to design and build, if you like, or what do I need to go to my suppliers for? I mean, you and I talked very briefly about things like GreenLake. I mean, GreenLake to an extent is taking some of that problem away from the customer.
Yeah,
but the
definitely.
reality is that it is quite a complex arena. But without it, we wouldn't be seeing some of the things happening in cloud that we're seeing now. So it was really my sort of homage, if you like, to hardware, because it's been left out in the cold.
But there is, I mean, there's also, I just kind of realized as you were saying, there's also a difference between the type of hardware that you have in the data center versus the type of hardware that you have in a cloud environment, a hyperscale data center from a public cloud provider, for example. So,
Why
I mean,
do you say that?
well, I do. First of all, I just going back to your point about the trading system, I do actually. Yes, I had an example of myself. So when I actually worked for IBM many years ago, one of the customers that I had, who shall remain nameless, one of the complaints that they were making actually to us, and they were running some trading deal kind of complex application in their data center. It was, wall-to-wall IBM hardware. And the complaint that they made to us was actually your management processes taking too much time. The IRQ on the management processes putting a load on the overall process and therefore the overall performance of the system. So we actually had to go back to the drawing board and rewrite or update our BIOS firmware, our BIOS code, to actually allow them to have an option to disable the management processor, the what some people might call the ILO sort of processor, and because they didn't actually want it. The whole thing was kind of managed in a different way, or it was kind of a commodity, it's dead, swap it out, don't worry about it kind of approach that they had. And the management processor was becoming a nuisance to them, to their performance, to their benchmarks. So they benchmarked, I think, IBM and Compaq at the time, and or actually maybe it was Dell, I can't remember, but I think it was around sort of the mid 2000s, and they said, we need to disable your management processor so we can get this benchmark, evenly done. So yes, I do empathize with that. I had kind of a similar situation. So just going back to what I was saying is because, in the hyperscaler, we don't really management processes and things like that are not, as far as I know, they don't kind of work in the same way. There's a different approach to that. And also the designs for these servers, whether they're 1 user, 2 user, whatever they are, or they're story, disk heavy or something, tends to be, very commodity and designed specifically for those hyperscale data centers. So, I mean, I wouldn't expect to see an IBM server or an HPE server or a Dell server in a hyperscale cloud environment. I'd expect to see a Hynix or a Foxconn or something like that, which is extremely specific and doesn't have a cover on it. According to the Google video that I saw, the Google Cloud video that I saw, it's the power supply is some kind of weird configuration. I can't remember this. I'll try and maybe put some links in the description for the videos that I saw. So the power supply is kind of provided in a different way, and the way that they manage it and maintain it is also done differently as well.
Yeah, a lot of that is down to the Open Compute project, which is come with this
potentially, yes,
different way of making it a lot easier to manage. But you used an interesting term, which was commodity, and to an extent, yes, it's commodity in the sense that it's a standard, x86 architecture, or it's a standard ARM architecture, and there's not a lot of extra management put into that, if you like, overhead put into that from suppliers these days. But I rail against the sort of commodity idea, because actually standard commodity servers don't really exist anymore. So even if you're getting a Dell or an HP or a Lenovo or whoever the badged OEM servers are, they're still, delivering quite specific configurations these days, rather than the standard. When I worked for Unisys and we had a server division, and there were standard servers going out. I don't remember ever. It was almost a case of you can have any color as long as it's black. The old Ford mantra. And the idea was just add another server if you need a bit more power type approach. That's going back into the late 90s. And Unisys did come out with a scale-up one that was very interesting, but ultimately doomed to failure. But the other thing that amuses me is that actually, if you look at the architecture of a mainframe, it's doing quite a lot of the same things in the same way that we're now having to do to offload processes, because obviously they had much lower power, less memory, less disk. They had to offload stuff. And they boxed it up in a box that only they understood. Which sounds a little bit like giving it to AWS, because you boxed it up in a box that you don't have to understand. But they're having to use a lot of the same techniques now, because the software has become so complex, and the demands of the online real-time world have got so enormous. You can't use standard commodity architecture. You can use the architectures, but you have to do things to it.
Yeah, I understand that, and we could probably go on talking about that for quite a bit. we do have to move on, unfortunately.
I'm an old tin man.
You're into the tin stuff.
An old mainframe.
I understand that, and I appreciate that. And like I said, I think again we could maybe kind of push on things like, well, some of that stuff's actually being done in software now. So even like HPC and so on is actually being done in the cloud, and so on. So they really don't have to worry about the hardware anymore. SAP is kind of moving not just into, as a specialist application, not just into the cloud, but actually being containerized as well.
You see, I think that's a slight distortion. You don't have to worry about the hardware, because as the software gets bigger and bigger and bigger, you've still got to process it somewhere, and so there's this sort of, okay, it's all in software, we can just have small servers. And you sort of go, well, hold on a minute, guys. There's a lack of logic here. Yes, you're doing a lot more in software, but the software still has to be processed. And so I think there's a danger that you think, actually, I just need cheap commodity hardware. No, you don't. You need quite specialist hardware to run what's going on, and I will keep making my case.
That's I understand that, and like for example, the gravitons from AWS they've certainly gone down that route for a specific reason.
Absolutely. I mean, and the great thing about going to AWS as a customer is you don't have to worry about that. You tell them what oomph you need, what processing power, what scale, etc., what latency. It's up to them to deliver it. So
okay, right, we definitely got to move on now. So okay, so the second one that you had was how does data live in a stateless world?
It was an intriguing one for me, because I've over the course of the last few months, I've got more and more entangled, I think is the best word, in the need for quality data, the needs of data, and the needs of systems to have good data to work with. And that's I just came across an article that somebody was complaining about the fact that, containers by their very nature, and Kubernetes as well, is stateless. Once the transactions happen, you turn it down. You don't need to have kept any of that detail. It just disappears into the ether. But actually, data and databases particularly are stateful by their nature. And actually, when if you're doing analytics or you're doing anything where you need to keep a record, it has to be held somewhere stateful. So I was sort of quite curious. Well, if containers and Kubernetes are effectively stateless, how the hell do you handle data? So I looked a bit further, and I sort of raised this topic and then decided to look a bit further. So I can see how, using things like persistent volumes within Kubernetes, or some of the sidecar type approaches that are used within a container world, gets round the problem. And so I'm less concerned that it's an issue. I think Kubernetes does control it. But the thing that sort of came back to me quite strongly was that, again, you've got another area where development has run ahead of the ability of the rest of the system to keep up. We talked about GitOps and the rise of GitOps and its, role, if you like, in sort of providing a single source of the truth and getting to grips with.
I wouldn't go that far.
Well,
having spoken to a few DevOps people recently and platform engineers, they've got some choice words to say about GitOps.
Well, we'll come back to that one certainly.
I think we will.
And I'm definitely not a GitOps expert, but it did seem to me to be again another of those sort of reactions to, we haven't got the right level of control or visibility or whatever. And to an extent, the data one struck me in the same sort of way. Is that you go plowing on with all these great new agile development tools, and you suddenly go, what do we do about that? I hadn't thought about that.
And data,
and I think that's partly driven by the fact that cloud is now, the cloud environment is now really starting to meet the old, legacy type applications and obviously the needs of systems of record. And at the moment, people are going, systems of record, and I'm keeping away from the cloud. Well, we're going to have to address that at some point in the future. So I was quite intrigued to see. I would be useful. I'm sure one of your 15-minute slots will look at, how data is handled in a container environment. So I think that's worth having a look at, and I'd certainly watch it with interest because it's, I'm more and more aware of the need for data to be handled in the correct way to make cloud, to make analytics, to make AI work properly. And if you're just in danger of adding more and more complexity to the development and management environment if you have to react after the event. So again, it's been a theme of mine in the past that says agility and velocity is great. But you shouldn't do it at the expense of good architecture.
And let's not forget that Kubernetes kind of started life as a sort of focused on stateless, conditions and applications. But having said that, let's just say, it started life like that, and then they realized that actually 99% of applications are stateful. And so we have to go back to the drawing board. So they kind of come up with those ideas, and also things like the data on Kubernetes community, for example, has actually been sort of focusing very much in that space. Shout out to Bart Farrell, who's the CNCF ambassador who leads that, or has been leading until recently, leading that the OKC community. So those guys have kind of really focused on finding solutions, and there's vendors in that, there's enterprises in that, there's kind of the whole sort of development community and so on, and that's geared specifically for that type of space. Also on the other side is the kind of how do you do networking and how do you do storage. So those have been actually, the initial versions of Kubernetes had those in tree, as they say. So the actual code for doing networking and storage was actually part of the Kubernetes code, and that's kind of been modularized, if you like. It's been taken out of that sort of main code, so that you can have integrations from third-party vendors. So so the likes of NetApp and Pure Storage and Portworx and people like that have all written a CSI module, so to speak, which allows Kubernetes then to be able to address their storage platforms and storage solutions.
Okay, I mean, it's an interesting sort of snapshot, if you like, of the way in which the whole IT world, whether it's cloud but cloud driven, is pushing into the sort of more legacy space, and how do you actually bring that together, and what are the interfaces like? And I think that's going to continue for some time. So that's interesting to hear, and I'm sure we'll hear more about that.
Yeah, I think the CSI one is in a, I might be getting this wrong. I never remember these acronyms on when I need them. I think it's the container storage integration or interface, and then the networking one is the container network integration or interface.
Interface, probably.
Yeah.
And obviously the importance there is that the interface remains consistent.
Yeah, so there is a standard format for that. And like I said, then it's up to the vendors. So like NetApp, if they want to introduce their SANs or NAS solutions or pure storage or somebody like that, want to introduce that, they will just write a CSI, and then that allows that Kubernetes distribution to be able to go and talk to that platform and make use of that.
Yeah, from my perspective, again, coming with my sort of legacy background as well, the other area that intrigues me, and again might be one for a future time, is when is it right to do microservices-based applications, and when is it right to do a monolithic application?
Yeah.
And as you run into this integration piece there with the sort of systems of record, that will be an interesting debate for the future.
That will be definitely a great one. So one last point on this topic, though, was I was talking to somebody recently, and they said, well, one of the things that you can potentially do or consider is when you're kind of looking at a workload or an application that maybe for regulatory reasons or something needs to keep the data, that system of record that you mentioned, for example, on-prem, for example. So what do you do? Well, he said, well, you can potentially look at only migrating the stateless parts of that particular workload. So it kind of got me thinking, just to maybe not just to look at the whole thing, but saying, okay, well, maybe we can't move the data, or we haven't got the ability to move the data right now. It's just not feasible. So let's kind of look at that as a secondary thing, and only kind of move the aspects that we can. Obviously, that has its own implications, because kind of potentially stretching the application or the workload, and then you're now looking at a hybrid solution, for example, and whatever, that might complicate things. But maybe kind of.
I mean, the whole area of what do we do with existing apps? Are they going to need to be reconfigured or redesigned to take advantage of these sort of things? Don't know. But it's the world is getting complex. Doesn't need to be complicated, but it is getting more complex.
Yeah, certainly. I think the cloud native space is getting very quite complex. Is it slowing down? I don't know. I think that remains to be seen. Certainly, some of the ways that we can do it. So we mentioned GitOps earlier. Is maybe complicating things, or kind of throwing more into the mix, if you like.
Yeah, I think the technology will always move really quickly. I think maybe people need to take a sharp intake of breath and sit back for a minute and think, how do they do this sometimes? So I think if you just chase the technology, it'll keep going as fast, but we'll keep having challenges in managing it afterwards.
Yeah, and we'll maybe revisit the whole sort of DevOps, platform engineering, and GitOps sort of thing in a future talk as well. Okay, so on to the third one, which was AI. So my question, and you and I have been corresponding on this for a while now, but my question was kind of why AI now? Why ChatGPT just in the last 6 months? Why haven't we been able to do this kind of capability before? And I'm sure there's lots of really, interesting reasons and whatever. But we've had, as far as the technology is concerned, we've had the AI and ML sort of libraries and algorithms and so on, for decades. Most of those have been open source, at least in the 5-10 years. I'm not kind of up on the history of it, but that kind of ability to experiment, through cloud platforms, using cloud platforms to kind of make it more, agile, and to test something out and fail fast and try different data sets and so on. That's been around for a long time. So why is it only kind of why sort of OpenAI has managed to do something recently with ChatGPT that others haven't? And again, I'll maybe kind of make a little note on that and say, yes, we have had kind of all manner of AI powered systems. So like on websites, they can, if you want your background to be removed on a photo, you can do that. If there's something in a photo you don't want it, you can kind of go to a website and it will use AI to kind of remove that. So that's fine. But those are very specific. They're not kind of in this approach of how ChatGPT has been, where it's kind of a universal or pervasive type of platform where you can, relatively speaking, on the whole, 95%, 98% successful in terms of what it's the answers that it provides you.
I mean, you're aware that, from my perspective, I think there's a coming together of various technologies that have made it easier for people to get to some of these. Particularly, in terms of the speed of development of new AI, it's been democratized by the cloud. So if you go back a few years, AI was being done almost exclusively, in laboratories on premises, and actually it's very expensive, and so relatively few people were able to spend the time and money that training AI systems that was necessary. And the cloud's changed that. I think that's number one. The other thing I think that's why ChatGPT now, and I think we have to take a slightly different view. And it's again, even in the last few days, there's been some interesting stuff kicking around neural networks, and this sort of whole issue of the explainability of AI. And actually, when you look at the history of that, it's not explainable. So I think there's been a lot of suck it and see experimentation going on over the years because they actually don't know in a neural network how the input gets used between the various layers in a neural network and gets to the output layer at the top. And nobody seems to be even going back into the very earliest stage, because they were playing around with analog neural networks back in the 50s. And nobody seemed to be able to understand how it was doing what it did. And they were getting the results by trial and error. And I have a feeling there's been quite a lot of that trial and error going on, number one. And the other reason I think is that, this ability now, to provide so much training data, and you've now got IoT come into the mix. So you've got data flowing at you from all over the place. So the actual amount of data, you can potentially train things much better, but you then need the power to be able to do the algorithm, do the actual processing. So I think neural networks, I think ChatGPT is very much based on neural networks, where a lot of it is algorithmic, machine learning a little bit, whereas I think ChatGPT and some others, this sort of natural AI almost, is neural network based. They're trying to mimic the way the brain works, and I just think they've been sucking it and seeing for years, to the point where it now works.
I agree with that to a point. I mean, I think it's just looking at some of these giants, Facebook and Google and Microsoft and Amazon and so on. I mean, it's taken a relative nobody to come up with ChatGPT, and then for Microsoft to go, oh my God, 49% investment, thank you very much, I think we'll do that. And it's kind of woken up the giants. And then you've got Bard from Google, and and then I think AWS, you'll probably see Amazon or AWS kind of doing something later on this year around that. I know that for certain. So why didn't the giants do this? Because they don't have some of those restrictions, the data sets, the hardware, the platforms, the development teams, and so on. So that's a strange one.
It's a strange one. But I read a good Forbes article, and I'll give you a link to it. You can use it on this. Only I think yesterday or the day before, and I read it. It was fascinating. And one of the things that came out of that was where, Andreessen said, software's going to eat hardware.
Yeah.
He's now, he's not saying, but the industry seems to be sort of suggesting, maybe even Andreessen himself is suggesting, that AI will eat the software. And one of the things that Forbes was pointing out was that actually it's not in the interest of a lot of the big software companies. Now, it doesn't excuse AWS to an extent, but a Microsoft perhaps may be.
Yeah.
And it's not in their interest to kill off the revenue streams from software, because AI is going to do it for you, And so there hasn't been a focus within software companies to really get to grips with AI. So it's been the startups. And one of the article goes into, all the sorts of startups that are coming. And it hasn't been the big boys, because actually it wasn't really in their sort of business plan. One of the challenges of getting to be a very large organization is that sometimes you miss the obvious things sitting in front of your face. I mean, it's well known over the years. You get a little bit of myopia, a little bit of marketing myopia or product myopia, but also some self-interest. And it's like, oh, flip, right, I missed that one. I need to get on board with it now. So there may be an element of that. It was an interesting angle, which I hadn't thought of, that the software companies maybe had no interest in doing it because they could see it would cannibalize their revenues.
And I mean, I think to a degree there would be a just kind of that sort of stuff maybe bubbling under the surface for some of these big players. I mean, Google didn't put BART together, over the weekend or something. It was clearly something that they'd been running. And we did hear some reports about, I think, one individual who was working there who was, dismissed or left the company, whatever, due to some comments that person made, in the public and so on, regarding AI platforms that Google has in research. So, I mean, whether that was kind of to the degree, that it was or claimed to be or not is not really that important. But it just seemed to be, something that I can see the angle that you're saying about, it wasn't in their interest, and it's the same as the kind of the hardware vendors of the data center kind of not seeing cloud in their interest really, and they still don't see it in their interest, although they've kind of reluctantly, begrudgingly kind of started doing some moves that will kind of go in that direction. But I can that was kind of it's just been interesting. It could be a meeting point of all of those things that we've kind of maybe talked about.
I am famously not a person who believes in any form of conspiracy theory, because I don't think everybody is smart enough.
This is not the channel for conspiracy theories.
It's like it is just a coming together of things at certain points in time. Short-sightedness on some, opportunities on another side. Plus, as I say, I think the changes in technology in the last few years have made it viable for more and more people to get involved in AI development.
You've got me thinking about the self-preservation and the kind of not laziness, but the cash cow kind of thing.
It's incredibly difficult. I mean, any follower of and I'm sure we'll come back to this sort of history of technology phases, that there are always problems with the incumbents being prepared to eat their own children, effectively. Lovely term, but effectively, as you say, killing
please
off
don't try this at home. Please don't try this at home. Disclaimer.
Disclaimer.
So, I think, I mean, I do sort of appreciate that. I just would have thought it would have been slightly different. The scenario would have been OpenAI tries this, it doesn't work, but it was on the right track, and then Microsoft either says, or somebody, one of these big players says, that's an interesting idea. They try to kind of open the they try to kind of open the tap to the internet sort of thing, and then kind of make it universally available. why don't we buy them out or rescue them, or actually forget them, let's just do it ourselves. And then it would come from one of the big players. Whereas actually the scenario has been, no, nobody has kind of come along, and well, potential nobody, although they're sponsored by Elon Musk and people like that, but they've come along and done it. And now Microsoft's going, oh, I think we need to invest in them.
Yeah, I think one of the things we've seen over the last few years is the need for speed means that you can't afford the 2-year gap to catch up.
We're talking Top Gun now.
If you've done it yourself, bring your own people on board, skill them up, get all the plans going. If you've missed that, you need to buy somebody because you can't afford the time not to. And that happens over. In fact, an awful lot of startups out there work on the basis that if I do this right in 2 years, in a couple of years' time, a bigger company will come along and buy me because they haven't got the time to, now to spend that we've just spent. It's an interesting model, which is sometimes a little bewildering, I think, but never mind.
So the report that you sent me, which was very interesting, the McKinsey report, State of AI, I think up to last year. So they've apparently, I'm going to just touch on a few. I will provide links in the description so everybody kind of watching can have a look at that. But it was an interesting one, and it was actually one that's practical at last, not kind of guessing and putting a whole bunch of stuff together, and a report that refers to other reports, which is normally what you get. You get an article or a blog, and then it says Forbes says, or Gartner says, and it's like, no, do your own stuff. I want your stuff. I want your opinion, not somebody else's. But anyway, the McKinsey report, State of AI 2022, said they've been tracking AI for the last 5 years, apparently. So AI adoption, apparently since 2017, has more than doubled. So it's around, I think, 2.5 or something like that, in terms of organizations using it. And this was a survey that did of a bunch of target organizations. Increased capabilities of organizations to do AI. So there's lots more kind of people in an organization actually doing AI stuff. So natural language generation and computer vision seem to be kind of the two top areas there. Average number of capabilities for AI has gone from 1.9 in 2018 to 3.8 last year. That's the number of people that were surveyed out of 100, I presume, or something. But yeah, we've kind of seen things like VAR systems, robotic process automation, or RPA. They mentioned something around virtual agents or conversation interfaces. So I guess kind of chatbots and things like that. Digital twins, which I think you've mentioned.
Chatbots.
Yeah. And the digital twins, which I think you've mentioned in the past. We've not gone into that, but we might do sometime. And then recommender systems. So these were kind of the top, I think, 4 or 5 main sort of things, as well as like I said, the natural language generation and the computer vision seem to be part of that. Interestingly, the report said that the use cases kind of pretty much remained the same. That's kind of been flat in terms of where it's being used. It's not been a kind of a new space where it's kind of come through. Although I'd probably say something like ChatGPT, and I don't know what you would class that. Is that a natural language kind of platform? I don't know, but I think it is. I can't remember, but certainly kind of everything else has pretty much remained the same in terms of kind of use cases for it. So those were kind of some of the interesting things I think that appeared around it. And then I think the other one which was interesting, and this might go back to what you were saying in terms of the level of investment has actually increased. So of those surveyed, 40% in 2018 said they were doing something with AI, and last year, 2022, 52% said they were doing something with AI. So that's a very healthy growth, I think. And
I think if you look at this investment, the sort of market for angels and sort of VC funding, there's a lot of focus then on the AI space. So a lot of people making bets on it. How many come to fruition doesn't matter, but the VC market is definitely AI focused at the moment.
Yeah. Yeah, indeed. And I think the last point that I picked up on was, and I think this is, prevalent elsewhere in other IT sectors as well, is the talent and expertise is still trailing behind. There's still not enough people in those spaces that can kind of, to fill the skills gap. So there was talk again about reskilling and upskilling within that, which is fine. But again, as we always keep saying, you can certify and stuff like that, but you need really the experience and the knowledge.
Yeah, and you need a stream of people coming out of the education system who are at least, able to be upskilled, I think, and had that discussion before. And I think, some geographies, particularly in Asia, are probably going to be better placed for that than we in the West are. So
yeah, indeed. Right. So I think we've come to the end of another edition. Paul, thank you as always. Really appreciate your insights and all your commentary. It's been very useful and certainly got me thinking a couple of other directions for some of the topics that we've discussed. So I appreciate that. All the links of the stuff that we discussed will be in the description of the video. So do check that out. And yeah, and give us some comments of yourselves, maybe some other areas that you might be interested in us talking about in the future, or certainly make some of your own comments on the topics that we've discussed for today. Thank you for watching, and we'll talk to you next time. Bye for now. Thank you for watching this talk. If you enjoyed the content, please comment, share, like, and subscribe to support the channel. You may also want to check out some of the other videos on this channel. See you next time.